guys, today we're gonna talk about regular expression, guys. If you guys hear about regular expression, what do you guys think about? Hard, complicated. Hard, complicated. Pain, gone, sadness. Oh, sorry, I wrote double pain. Hi, David. Annoying but fun. At least we got some positivity, right? Suffering. Wait. Annoying but fun. I like that. I'm interested. I think So Knackered is like, if you ever played marbles, I already know what your name will be, So Knackered. It will be with Secretary's name. We got archaic format, is that right? It's used in web scrapping. Really? Scraping, sorry. Scrapping, sorry. Oh, I got a perfect one for you, Tyvin. But you gotta play it. We play it on Sundays if you wanna come. When you figure out a complicated regular expression, you feel really satisfied? I think you were born to be a programmer. Coder, because actually I do understand that feeling, because that's what I felt when I was, doing machine learning. And if I got like my R² value to be like a beautiful number, I forgot, is that like, what was it, 100, like one closer to 1 is good, so like 0.98 or something, obviously because it was a school project. But if I got it to be that high, I'm like, genius, I'm gonna make the next Google, guys. Totally understandable. So let's read about regular expression, guys. Let's see if it's really hard, complicated, pain, gun, sadness, suffering but annoying. Oh, sorry, suffering, annoying but satisfying. Like blah 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 blah, etc. Yeah, I'm an ex-Googler. So can you guys see? So regular expression, shortened as Regex, Regex, right? Regex. Also referred to as rational expression, is a sequence of characters that specifies a search patterns. Usually, such patterns are used by string searching algorithm for find and replace operations on string, or for input validation. Oh, it's regex? Okay. The concept of regular expression began in 1950, guys. 1950, when the American mathematician Stephen Cole Kleene, right? Formalized the description of regular language. They came into common use with Unix text processing utilities. Different syntaxes for writing regular expressions have existed since the 1980s, one being the POSIX standard, and another widely used being the Perl syntax. Oh, so it's connected with Perl. We've heard about Perl, guys, right? Now, regular expressions are used in search engines, such search and replace dialog of word processors. Wow, used in search engines. Text editors in text processing utilities such as sed, awk, and lexical analysis. Wow. Is this actually pronounced as AWK? Maybe. Many programming languages provide regex capabilities, either built in or via libraries, as it has used in many situations. It has uses in many situations. Oh, so SED and AWK are Linux. Ah. I've actually used it in my old programming classes, but I've never figured out why and how it's been made. So let's read about the history, guys. So, regular expression originated in 1951 when mathematician Stefan described regular expression using his mathematical Jinri English, hallelujah, mathematical notation called regular events. These arose in theoretical computer science in the subfields of automata theory. Shh, guys. And the description and classification of formal languages. Other early implementation of pattern matching, including SNOBOL. What is this? Snowball? Is this how you pronounce this? Snowball? It sounds like noble, but with an S in the front? Which did not use regular expressions, but instead its own pattern matching construct. Really? Oh, what is snowball language, guys? So regular expressions entered popular use from 1986 in two uses. 1968. Pattern matching in a text editor. Wow. In 1968? So old. And lexical analysis in the compiler. Seems like we've been hearing lexical analysis. So this is Linux command? Right? So Snowball is a variant of COBOL. Oh. It's not Linux, sorry. It's plain English? Oh! So it analyzes in the compiler plain English? Oh shoot, wow, 벌써부터 already, alphabetical analysis? 그냥 영어예요? 그냥 영어. Just English. Just English. Not even just analyzing English, it's just English. Oh. Why can't they just say English? Why did they need another name for it? Anyways, among the first appearance of regular expressions in programming form was when Ken Thompson built Clean's notation into the editor QED as a means to match patterns in text files. 아니에요. 계속 얘기해주세요. For speed, Thompson implemented regular expression matching by just-in-time compilation, we've heard of it, to IBM 7094 code on the compatible time-sharing system. So it helps with speed too. An important early example of JIT compilation. We've heard about just-in-time compilation before, right? He later added this capability to the Unix editor ed, which eventually led to the popular search tool grep's use of regular expressions. It's what? Also, it's maybe like expression regular edit p something mobabi. Also, at this time, JIT compilers were the leading. So they were the best. 최고, 따봉. Best one at this time. So around the same time when Thompson developed QED, a group of researchers, including Douglas, implemented a tool based on regular expression that is used for lexical analysis, aka English. Right? in compiler design. So what is pattern matching in a text editor? So if you have a text in a text editor like Word, right? It finds the pattern. How? Oh, so I guess this is, I don't know what pattern matching is. Find out soon. Okay, let's continue reading about it. So many variations of these original forms of regular expressions were used in Unix programs at Bell Labs in the 1970s, including V, Lex, Sed, Awk, and Expr, EXPR, and in other programs such as Emacs. Regexes were subsequently adopted by a wide range of programs, with these early forms standardized in the POSIX.2 standard in 1992. So there were other regular expression forms like these. This is a variant of regular expression. And since you mentioned these two, these are Linux. 맞나? 이게 맞나? Is this correct? If you have 0 to 9, then you find numbers in the text. Oh, so it's kind of like text finder? We're getting somewhere, right? In 1980s, the more complicated regexes arose in Perl, which originally derived from the regex library written by Henry Spencer, who later wrote an implementation of advanced regular expression for TCL. The TCL library is a hybrid NFA-DFA implementation with improved performance characteristics. Software projects that have adopted Spencer's TCL regular expression implementation include PostgreSQL. So Postgres use SQL. Postgres use regex? Really? Perl later expanded on Spencer's original library to add many new features. Part of the effort in the design of Raku, which is Perl 6, apparently this was the worst one, right? Is to improve Perl's regex integration and to increase their scope and capabilities to allow the definition of parsing expression grammars. The result is a mini language called Raku rules, which are used to define Raku grammars. The use of regex is structured information standard for documentation and database modeling started in 1960s. So it used to work for text editor matching patterns. So it's regex is actually used for data stuff. Data management, right? A lot of things can utilize regex. Python, Java all have libraries. Yeah, that's what I thought. Thank you, Gundam. Worst language, but a mini language came out of it. Yeah. And it all started out maybe from the pattern matching. So maybe in school I used regex, but I never knew that was that. So let's see why regex is so difficult then, right? Annoying, difficult, but satisfying. Wait, maybe I don't... Because there's patterns? Regex memorize patterns for you? Let's read the next section. Yeah, next section is important. So let's read from today regex are widely supported in programming language, text processing programmers, advanced text editors, and some other programs. Regex support is part of the standard library of many programming languages, including Java and Python, and is built into the syntax of others, including Perl and ECMA script. Implementations of Regex functionality is often called Regex Engine, and a number of libraries are available for reuse. In the late 2010s, several companies started to offer hardware, FPGA, GPU implementations of PCRE compatible Regex engines that are faster compared to CPU implementations. So there's also like official hardware engine that works best for Regex engine. So related to data. 정규 표현식은 이게 한국어로 정규 표현식이에요? 필요할 때 찾는 게 국룰이라고? Regex가 한국어로 뭐예요? We heard about ECMA script. Jinri 0-9 plus is pattern. That is pattern 뭐시기저시. Pattern matching. Regex is Regex예요? 정규 표현식은 뭐예요? So in my name, you're finding a number from 0 to 9? Regex 아니래잖아요. 저기 있잖아, 정규 표현식이라. 그러네, regular가 정규, expression, 표현. Guys, in Korean, it's 정규 표현식. 정규 means regular, 표현 means expression. 매칭이 안 됐어. 대박. Thank you, 따봉. So let's continue to patterns. The pattern regular expression or regex is often used to mean the specific standard textual syntax for representing patterns for matching text. Okay, as distinct from the mathematical notation described below, each character is a regular expression. That is, each character is a string describing its pattern, is either a meta character having a special meaning or a regular character that has a literal meaning. For example, in the regex, B is a literal character that matches just B, while dot is a meta character that matches every character except a new line. 저거 AI로 대충 데이터 몇 개 주면 목적 패턴 추출해주는 사이트 어디서 본 거? So it's used in machine learning? Did you guys see the wrinkle in my head? Wait, so each character is either a meta character or regular character. So regex has two different characters. A meta character, guys. What is a meta character? 감사합니다. 영어 듣기 좋죠? Character describes a character is meta character? So, meta character is something that represents one or more character. So wild card. Maybe wild card. Right? Oh shoot, guys, let me move into so meta character are like the symbols, right? Special meaning. Wild card. Special meaning. Okay. 그 다음에 regular character are regular character. So that's why B is a literal regular character, while dot is a meta character. It's like a rap, guys, right? Yo, check it out. Woo. 죄송합니다. 자, okay, continuing. B is B, which is a regular character. Dot is dot, which becomes meta. Woo. Combined, you get regular expression. So you combine a regular character and a meta character. So regular characters are just A, B, C, D, E, F, G, 뭐 etc, 1, 2, 3, 4, etc, right? Okay, continuing. So therefore, this regular regex matches, for example, B %BX B5 together, meta characters and literal characters can be used to identify text of a given patterns or process a number, for instance, of it. Pattern matches may vary from a precise equality to a very general similarity as controlled by the meta characters. For example, dot is a very general pattern. A to Z match all lowercase letter from A to Z is less general, really. And B is is precise. Of course, because everything's gonna have a dot. That's why it's can be a pattern matching in a text. Oh, I see. Yeah, A to Z is less general. Oh, okay. And the meta character syntax is designed specifically to represent prescribed target in a concise and flexible way to direct the automation of text processing of a variety of input data in a form easy to type using a standard ASCII keyboard. 에스키 맞아요. Hi, who intern? So, regex가 뭐라고? 무슨 표현인데? 정규 표현식이에요, 한국어로. 나 겁나 똑똑했다 방금. Oh my god, I sounded so smart in Korean. Like I knew Korean in this. regex는 정규 표현식이라고 이제 구글에 찾아보시면 됩니다. 이거를 차마 한국어로 표현을 못하겠습니다. 나도 한국어로 이해는 못하겠는데 이게 뭐냐면요. 이제 어느 텍스트나 그런 거에 패턴들이 있으면은 그거를 이제 찾아주는 서비스 차원 그래가지고 데이터 분석이나 데이터 관리를 할 때 자주 쓰는 언어라고 생각하시면 될 것 같아요. 왜냐면 우리 데이터가 엄청 많잖아요. 이제 평상시 데이터, 심지어 나이트님의 여자 스트리머 보는 데이터들이라는 것도 많을 거예요. 그런데 거기 사이에서 이제 뭔가 패턴들이 있을 거예요. 이렇게 패턴들. 뭔가 뭐 저처럼 이쁜 여자들 위주로 보거나 안경 쓰는 언니들 그런 거를 조금 찾아주는 거에 도와주는 게 이제 정규 표현식이라고 생각하시면 됩니다. 진짜 겁나 똑똑해서 방금 한국어로 막 잘 설명 중이야. 텍스트 필터링 언어래요. 필터 서비스구나 그냥. It's just filter service. So I have no idea what I'm talking about, boss. You shouldn't trust everything. Oh really? Damn it. Literal characters, they represent themselves literally. Yeah. Do you know what you have if you have a lot of meta characters? A metaverse. Really? 혼돈이? Did I mishear? About what? That I'm pretty? 저처럼. I was explaining to a Korean. Oh, dude, I hate you. Don't confuse me. So what I just said in Korean, kind of giving an explanation to an intern who didn't know what regex was. But basically what it does is you watch a lot of girl streamers. You gotta filter somehow, and this actually filters like the part, right? You know, it finds the patterns of what type of girl streamers do you guys like to watch? Because you watching girl streamers, that's also data. That could be part of data. And that's why we're developing Tweety, because those data can end up being a 추천 service, a recommendation service. Tweety. That was my ad, guys. The streamer finding service. Regex can check if it fulfills all the requirements, such as lowercase. Oh, really? So that's why. Oh, so password requirements is using Regex. Because it goes through the things that they type and it filter out. So every time I put a capitalize, it automatically filters. Ding! 대박. So let's continue. A very simple case of regex expression in this syntax is to locate a word spelled two different ways in a text editor. The regular expression serial matches both serialized and serialized. Wildcard characters also achieve this, but are more limited in what they can pattern, as they have fewer meta characters and a simple language base, right? Because serialized doesn't even have dots, any wildcard like other characters, right? The usual context of wildcard characters is a globbing. What is globbing? Globbing 뭐예요? Similar names in a list of files. So it eats up all the similar names in a list of files, I'm guessing. Whereas regex are usually employed in applications that pattern match text structures in general. So for example, the regex matches excess white space at the beginning or end of the line. An advanced regular expression that matches any numerals in Wow. And also there's, I think, something called a regular processor. Translate regular expression in the above syntax into an internal representation that can be executed and matched against a string representing the text being searched in. So the processor goes through the line, a string of text, right? And does all the work for it, right? It's like the engine. Can I say that? Basic concept. Regular expression, often called a pattern, specifies a set of strings required for a particular purpose. A simple way to specify a finite set of strings is to list its elements or members. However, there are often more concise ways. For example, the set containing the three strings handle, can be specified by the pattern handle. We say that this pattern matches each of the three strings. In most formalism, if these exist at least one regular expression that matches a particular set, then there exists an infinite number of other regular expressions that also match it. The specification is not unique. Most formalism provide the following operations to construct regular expression. Oh, so we heard about Boolean, the OR, there's grouping, quantification, the wildcard, as you guys mentioned, the dots, etc. There's also theories involved, syntax, standard, character lazy matching, something about Perl. We're gonna kind of go through roughly, skip. this is something that we can't learn in like a day or two or a month or two. Yeah, I'm positive there is going to be a class just on this topic. So maybe we can look into some of the implementation. That might be something to look into. Oh. There's Unicode. Let's look at examples. So there's a meta character dot. I'm guessing this is an example. So what a dot does is it normally matches any character except a new line. Within square brackets, the dot is literal. So let's see. Let's look at the output. I don't even know how you can even learn this, guys. String hello world. We have a hello world and then an enter sign, right? We're going to a new line. So if this string, within that string, print how many length before the dot. Where's the dot? I'm guessing this is the dot. If it's greater than 5, print 5. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So it's greater than 5, so they print out 5. What? So this is some like trial and error stuff. What? 뭐라 카노? 뭐라 카는데? Where's the dot? Oh, is this the dot? Because it has 5 dots? But within the square brackets. Where the hell is the square bracket? What? Okay. So this is the pattern. 와, 진짜 어렵다. Okay, so another matching. Let's look at another matching, guys. Groups a series of pattern elements to a single element. When you're matching a pattern within the parentheses, you can use any of $1, $2 later to refer to the previously matched pattern. Okay, so it's within a parentheses. We're matching the pattern within the parentheses. So we're matching this pattern. Something is wrong with your page encoding, really? $1 is string number 1. Oh, really? It means if the pattern is, it matches the dot in literal. Okay. Here, 여기. Okay, here and here. So this is, we're grouping series of pattern elements, right? So we matched hello and O. Oh? 와, 뭐라 카노? What are they saying? Oh shoot, hi, hello. Okay, so it will match H followed by any 2 characteristics. Oh? H followed by any 2 characters. So EL and O, any 2. So it should be hello and ORL, no? And the O has 2 characteristics. 2 character. Oh! Is O the next O and space and W. Dot is asking for for the literal characters that comes after. Ah! 1, 2, 3, 4, 5. Then why this just give length 5? 1, 2, 3, 4, 5? Just the first 5? Nani? I got this one. 이건 이해했어. But this one okay. But it asks for the two characters in between. Because that regular expression is only checking to see if there is at least 5 characters. Oh. Oh, so this is at least sign. So, but even if it's in print, if thing, okay. So desu ka. Okay. Wow. Oh. Okay. Oh. No. Oh. Unfortunately, doesn't support with this height. Okay, we'll just keep moving. This example sucks. Oh. そうですね。そうですね。So let's check regex101.com. Oh my god. Ah, so this is what it's grouping. 어머. Oh, and then we got meta escape? Is that... Ah, so the first group, the first match is hello war with that, and then the first group you got hello and then .o. Where's the common token? What the heck is a common token? Whoa! So let's look at the common token one and then call it, because I don't know if you guys see, but I have like Steam coming out. So this one is simple apparently. Matches the preceding pattern element 0 or more time. So we have a string hello world. If the string, so inside it's EL and then common token O. There, if it follows this pattern, you print there is an E followed by 0, too many and print L followed by O. Whoa. So it does follow this pattern. Because it does this work. Wait, how is this common? How is this easy? Wow. Okay, well, let's conclude, guys. To conclude, everyone. Conclusion. Wow. 진짜 wow. Pain. Suffering. I see why annoying but satisfying, but I will never understand. Maybe I just got the satisfying part too. You know, then I was like, I see, now I see, right? But annoying. And kudos to those who do this. To those who use this for work. And then chat provided with a very useful tool is Regex101.com. So please use this to make your life easier and learn it on trial and error. So you can't even learn this, right? It has to be done by trial and error. Like, it's hard for a regular, normal person to understand this right off the bat. I think this class is going to be super hard to teach, but let's do a simple example for a phone number. Douche! Get away, get away! Don't submit problems on Discord for me to do regex on, guys. This is not a class. So. Yeah. That's it for regex, guys. I hope you guys enjoyed learning about regex through Wikipedia. Yeah, have fun doing this for your career. But yeah, don't forget to follow and subscribe.